Did everybody take that test? Still need to take it? All right. Within next couple days. Um, so what we're going to do now is we're going to move on to reaction types. There are 5. Okay, there's 5 reaction types. And we're going to talk about the law of conservation of mass. Okay? The law of conservation of mass. Does anybody actually know what that is? The law of conservation of mass. What's conservation mean? Maybe the ability to like restore something. Now, the law of conservation of mass is that matter cannot be created or destroyed. Have you guys heard that one? Matter cannot be created or destroyed. I'm going to write that down, actually. The law of conservation of mass is matter cannot be created or destroyed. Oh, I want a darker marker. Oh, that's the ticket. Matter cannot be created or destroyed. Now, this is the focus. This is our goal. Matter cannot be created or destroyed. We're going to be balancing equations the next couple days. That's our goal. Matter cannot be created or destroyed. Fascinating. Where does it go? Have you ever had like a fire, like a bonfire? You have a ton of wood. However, when it's done, all you got is this like tiny bit of ashes. Where's all the wood go? It turns into ashes. A little bit of ashes, but where's the rest of it go? No clue. Anybody? It actually goes into the air. It goes into heat. All right? That heat is where the energy is conserved, where matter is conserved. Matter cannot be created or destroyed. It's pretty fascinating. So when we're talking about balancing equations, we have reactants and we have products, and our goal is to create an equation where our reactants equal our products. And that's the law of conservation of mass. How cool is that? That's pretty neat. That's what I'm talking about. So what I'm going to do is I'm going to go over the different steps on how to balance equations. And if you go over these steps, it should be pretty straightforward on solving some problems. Okay? So one of my favorite examples is water. Okay? You take hydrogen gas. You take oxygen gas, and that creates a good old solution of water. Okay. So when creating water, when balancing equations, there's 4 main steps I like to do. Step 1. List the elements used. List the elements used. Okay, well, that's not too bad. That's not too bad. Let's see. I have, what's H? Hydrogen. I heard it. So I have hydrogen. And O, we all know, is oxygen. Okay. All right. Am I done? Do I only have 2 elements to make water? Okay, step 1's done. Step 2. Oh, yeah, I'll just write a big 2. Step 2. Tally how many of each element you have on both sides of the arrow. Okay. Man, tally how many of each element you have on both sides of the arrow. Okay, so let's check this out. How many of hydrogen do I have on the left-hand side? 2. I have 2. Very good. H2 means I have 2 hydrogens. I'm going to put 2 tallies. How many oxygens do I have?
2.
2. All right. So I'm done with my left side. Let's go to the right side of the arrow. How many hydrogens do I have? 2. How many oxygens do I have? 1. Okay. Now, if I check this out, is everything balanced? Because matter cannot be created or destroyed. My hydrogen has to equal my hydrogen, and it does. My oxygen has to equal my oxygen, but it does not. And that's why we balance equations. Okay, so my goal is to get both of my elements to equal each other before and after the arrow. So my third step is I have to add coefficients to balance the reactants and products. Oh, running out of space. Good enough. All right. To balance the reactants and products, I have to add coefficients. Now, when you add a coefficient, it affects everything that follows that number. So, for example, my oxygen, I only have 1 over here. So what times 1 equals 2? 2, right? We're doing pretty simple math. So I'm going to put a big 2 there. Okay. Now, when I do that, coefficients multiply. So what happens is I have 2 times 2. 2 times 2 is? So I have 4 hydrogens on the right-hand side now. But also, I have 2 times, we said there was 1 here, right? Like an invisible 1. So what is 2 times 1? 2. So I'm up to 2 there. Does that make sense that it affects everything in the compound? Okay. Am I balanced? Am I done? Well, let's see. Hydrogen has 2. Oh, hydrogen over here has 4 now. So I got to go back to the left side of the arrow for hydrogen. I need to get this total amount to 4. How can I do that? Multiply by 2. What is 2 times 2? 4. Okay. Am I balanced? I am balanced. I have 4 hydrogens, 2 oxygens, 2 oxygens, law of conservation of mass. That's pretty awesome. That's pretty awesome. Let's try one more. Let's try another one. All right. I erased this up here. Okay. Let's try one more. All right. Let's do CH4 plus O2 creates. Yeah, we'll do it. This is a little complex, but we'll do it. Okay. Step 1 says list the elements used. List the elements used. What all elements do I have? Anybody? Carbon. Another one? Hydrogen. Last one? That's it. Carbon, hydrogen, oxygen. Step 1 is done. Step 2, tally the number of each element you have on both sides of the arrow. Carbons, I only have 1 carbon. Hydrogen, I have 4 of them. Oxygen, I have 2. Okay, does that part make sense? Good on that? All right, on the right-hand side of my arrow, I have 1 carbon. Hydrogen, I have 1, 2, 2. Oxygen, how many oxygens do I have on the right side of my arrow? I have 3. I have 1, 2, 3. So I have 3 oxygens. All right, so I'm done with step 2. That was pretty good. Final step, I have to add coefficients. I have to add coefficients to balance the reactants and products. So carbon's already good. One, yeah, DJ. Yeah, what you got?
A 4 in front of H2O.
A 4? Let me. So like right here, a 4?
Yeah, 4 there.
May I ask why?
Because you need a 4 there.
That helps.
And you see a 4 there.
I already have 4 hydrogen on the left.
Yeah, well, you're gonna need to multiply 2 on the CO2, which is gonna bring the oxygen over more to the right side.
May I ask why I need a 2 on the CO2? Right now, carbon's balanced.
Just put a 4 there. At H2O, put a CO2.
You're supposed to do it because it's right.
I don't want to make it more complex than it is. 2 in front of the H2O. May I ask why I do that?
Because then you just times it by 2.
Whoa, I like that. So, all right, so 2 times 2 is 4. Okay, so now I'm up to 4 hydrogens. What is 2 times 1? So I have 2 oxygens here. How many oxygens do I have here? 2. So if I combine those, how many oxygens total? 4, right? I have 2 there. There's 2 oxygens. And I have 2 there, so I have a total of 4 oxygens. Now my carbon is balanced. My hydrogen is balanced. Oxygen, I have 4. Oxygen, I only have 2. So what should I put in front of that to get a total of 4? 2. You're exactly right, because what's 2 times 2? 4. Is everything balanced? And you're done. That's balancing chemical equations. Okay. So what we're actually going to do today, I'm going to erase this bottom part. What we're going to do today is we're going to visualize how to balance these equations and what it actually kind of looks like. I feel like if we understand that part, we'll be able to do the rest. Okay? All right. Can I erase this on the board here? Okay. So what we're going to do is we're going to do a little balancing activity. Okay? And what the balancing activity looks like is, all right, so let's start with the introduction. Okay? Now there's different numbers, and you always have to start off with at least one of everything, right? Because that just kind of makes sense. One of everything. All right, so let's see. How many blue circles do I have on the left side? 2. How many blue circles do I have on the right? So I got to double that, right? So now I have 2 over there. How many white circles do I have on the left? And white circles on the right? So I got to get this side up to 6. 2, 4. Smiley face. Actually has a really cool sound. Check this out. Let me plug it in. It's gonna make your day, honestly. Yeah, let's turn up the volume a little bit.
You know what would make my day? Give us the week off.
The week off. The entire week?
At least 4 days.
Well, what would we do? But you don't even know what the sound is. Check the sound out. So you gotta start with one of everything. Right? Okay. How many red circles do I have on the left? Right? So I have to double the left-hand side. Okay. How many white circles do I have now? How many do I have there? So I gotta double that sound. Right? Oh, it didn't make the sound. Oh, my sound's off.
No, I definitely 4 days off.
Okay, I'm ready. We gotta do one more. All right. Here we go. Wait, we already did this example.
Oh, it's ruined then.
But we'll do it so we can hear the sound. Okay, so I have one gray circle, one gray circle. I have 4 white circles, 2 white circles. So I gotta double that one. How many reds do I have? I have 4 total, so I have to double this one, right?
What's going on, man?
What just happened? Did you turn my volume down? A little bummed, honestly. Hold on, we're gonna make it work. I just want you guys to know what the 1, 2, 3, 4. There it is.
Oh,
man.
There it is. I knew it was somewhere. All right. So what I want you guys to do is on Google Classroom, I actually posted this activity, and it looks something like this. All right. A few of these, just define, you can Google the definitions, or a reactant, any elements in front of an arrow. Product is any elements after an arrow. But then what I want you to do is try level 1, 2, and 3. Okay, try it out. All right, and then when you get to the bottom, I will go over this as a class. But I want you to try level 1, level 2, and level 3, and you will find that I'm on level 1 right now. So if you go to the bottom and click on game, or I should say home, you can click on game. Okay, try the different levels. All right, and then just type in your score. All right. If you want to turn on your sound on your computer, I completely understand. It's a very satisfying sound. All right. But if you have any questions, please let me know. If you need a computer, you can go get a computer.